Hello, hello, hello. Good morning, everybody. Welcome to join this webinar in this lovely morning. I'm Sean, an application engineer from CADVision. So for every Thursday, we'll have a different topics for design and engineering. Today, the topic would be Destination Zero Carbon. And the subtopic is why sustainability is now the key driver of innovation. Now, before we start, I would like to check if all the audience are able to saw the screen as well as listen to the voice. Right? In your little toolbox panels for the webinar, actually you will find a chat place. If you have any problem, you could just type inside there to let me know, or you can call 1300-2238 for our help desk. Okay. So I believe in these years we are quite hear this term quite a lot. Destination Zero Carbons. Okay. In the last 10 years, we're talking about Destination Zero Defects. And now we have another criteria, Destination Zero Carbon. Right? Or we used to call it sustainability. Or in a layman term, green design. Or design for environment. Okay? So it's quite a popular concept. Like this picture we have here, right? I've been reading for a couple of articles, new design handbooks, ebooks, right, and some video clips, documentary, and I found this picture come out quite oftenly, right? The hand holding the green earth, as well as this, So it seems like many people is talking about this design for environment, and many people is polishing their websites with this nice green picture. But what actually is green design? How does it impact our business? How does it impact our engineer? And what actually we need to do if we truly want to implement this green design? Right? So okay. So what I can get right here is becoming sustainable is a 5-stage process. Right? We can divide into a 5-step, right, to achieve design for environment. Right? Every step has its own challenge, where we will discuss here what are the main challenge, what are the skills and competence we needed, and what are the innovation we needed, right? So in this very, slacking environment, right? How to actually implement design for sustainability without dragging by the recession, right? So let's see what are the first stage, right? The first stage is viewing compliance as opportunity. Believe all of us, the engineers, have looked into the standard quite a lot, right? As we want to ship products to certain country, we will but a must, in order to gain market share, to comply all of the regulation needed. So what are the regulation in sustainability in this green area? What are they? Okay. The green regulations currently, which one is tricky, is vary by country, by state, or even by city. For example, taking these plastic bags in supermarkets, for example, currently in Penang, we charge for 20 cents for a plastic bags if we shop and request a plastic bag. But in KL, hasn't. Means that this compliance is actually varying between country, especially in this green area. So very famous codes, for example, is like greenhouse gas protocol. This is a more general one. And we also have forest stewardship council code, for example. And for one very famous one, electronics product environment assessment tool, right? So all of these are voluntary code currently, right? I think in here, what we're facing the most strictly laws and regulation is in European country. For example, like for electronics is WEEE, Waste Electronics Protocol, some sort of things like that, right? So in order to understand these codes, let us share some case study about a car, right? So what is a let us define what is a voluntary code. Voluntary code is something like, it's not yet a law and regulation, you no need to fulfill it. But then why do we still go and our engineer go and read it, our manager still go and implement it, and we still go this that direction? Because this is voluntary. Why waste so many resource on voluntary things? We just follow the existing laws and regulation. Okay, let's see. On 2002, GM, Ford, and Chrysler, three American automobile manufacturer, they signed the California Air Resource Board Fuels Consumption and Emission Standard. Okay, at that time, there was just voluntary code. Means that you can comply, you can also not comply. Okay, but then why do they sign? Not just because that this law is a will of California people. When they sign, the people will like the branding. But also, the more true is 2015, these guidelines will become a law. Okay, they will, at the buffer zone of 10 years, okay, you cannot comply, but the next 10 years, you will need to comply. Okay. So what GM and Ford and Chrysler is, they eat the bitter nuts first. Okay, they comply, they R&D, and they gain what we call a first move advantage. So according to car implementation years of a few years that would taken to give a new concept of car, they're actually winning 2 and 3 cycles ahead of their competitors. Right? So stage 1, viewing compliance as opportunity. Right, so here there is 2 different concepts. One is laws and regulation, which is currently enforced. Another one is voluntary codes. Right? As a technology workers or business owner, right? We're trying to comply with the current laws and regulation, but also keep track on the updates of the voluntary codes and keep tracking when will they become into law implementation. Okay. So I wonder, since many of us, the industry in Malaysia is come from this electronics industry. So I wonder, do you know who is the biggest winner when the EU's European countries restriction of hazardous substance directive was introduced in 2006? Okay, do you know who is the biggest winner? This is a hazardous substance directive. Directive means it has become a law in 2006. And hazardous substance is the substance as inside electronics. Okay, for example, leads, chromium, those heavy metals that usually we found inside electronics that will actually bring health problem to users and the disposal stage. Right? So they ban it, they put it in a law and ban it starting from 2006. So who actually is the big winner and how he can overcome this circumference? Right? The answer is HP. Right? HP already realized that lead is toxic in 1990. Right? Before that, before the law come into existence, they have created a solder that are made of tin, silver, and copper. Homogeneous. We call homogeneous is this all material contained in one part. The directive sometimes cover part and assembly. They have different differentiation. So they create a technology that use of tin, silver, and copper to replace the lead. Right? They even go further to develop the chemical agents to reduce the oxidation and tarnishing during the process itself. So it's a continuous improvement. When we realize a problem and when we know at the same time this will becoming a concern of public, the news starting to come out, people get cancer, some research of in the biology, public pressure. When public concern is arising, HP took a very smart move. They start earlier. Okay. So what this we can conclude is actually companies that take attention to comply the laws or even voluntary codes, they will spot business opportunity first. Like HP, they will start selling their technology, they will start patent. Right? So in 2002, WEEE is also asked hardware manufacturer to pay the cost of recycling products in proportion to themselves. Okay? If they are recycling contain hazardous substance, they would need to pay the cost as well. HP, Sony, Brown Electrics, they create a platform with 1,000 plus company worldwide. Okay? So recycling 200% of the coverage, the cost reduced is 55%. HP alone itself saved 100 million US dollar. They're creating a recycling platform. Currently, it's a very good business. When I travel in Ipoh, I found a lot of these recycling lorries actually in the business. Okay, this is one of the new business. So the company who start first actually spot this opportunity. So to summarize the stage one, right? Actually, stage one is more like a background, things like we do every day, applying compliance, and very contrary to popular perception, what we think daily. Actually, when we're trying to climb to the gold standard, means a stricter, difficult standard, actually save company money in the other ways. By gaining market share, that is another story as well. Right? As we keep doing these continuous improvements, R&D, and so on. All right, let's see what is stage two. Stage two is making value chains sustainable. So value chains, what is value chains? Value chain is from raw material acquisition, suppliers, to designers, to contract manufacturers, right, to logistics, to marketing, sales, and distribution, okay, retails. So in Malaysia, I believe for some industry we cover in raw material acquisition. Yes, we export woods, and we export a lot of stuffs, petrols, crude oil, a lot of things, tins, rubbers. But then we also have quite a waving in the world in the next two supply chains, which is engineering designs as well as this contract manufacturing. Okay. So usually usually this one will start as a value chain. So a thing to notice that we call it vertically, whether our supplier and our customer is already going this way, or horizontally, whether our company is already going this way, right? So in stage 2, no matter whether you go first or others go first, the final purpose is also the same. The challenge is to increase the efficiency throughout the value chain. Means that you start doing design and you will find many problems. You will find, okay, where can I source the part? How do I know the part is also designed in green or comply in the things? I need some document to support me. And my customer, how do I let them know that I'm actually really doing this green design, not just putting some nice green picture, right? So the competence needs here is professionalism in technique such as carbon management and life cycle assessment, right? And process R&D, the ability to redesign operation to use less energy, water, produce fewer emission, and generate less waste. Okay. For example, okay, we will need in the stage 1, we will need some concepts about how these people, this law and directive calculates our design's environment impact. Okay. And second thing, your production line. After we know our goal, how do we measure? How do we sampleize? How do we document the impact we made during the production? All right. So here, the main responsibility will lie on the first 1, 2, 3, raw material acquisition, part designer, contract manufacturing. Okay. These 3 will bear the biggest responsibility in doing these jobs. So what is a sustainable design life cycle assessment? So we call it, this is from a cradle to grave. Cradle is from a baby to grave, from birth to die. It is a cycle. So it starts from raw material extraction, material processing, part manufacturing, assembly, product use, end of life. Especially in raw, the complete laws and regulation, they cover all the region, the impacts to the environment throughout the cycles, right, would be covered as well. Right. And how do they classify the impacts of these environment impacts? Okay, what is the unit they use? They will use carbon footprint. Okay, how many carbon you produce along the cycles. Okay, this carbon is more to mean that how many CO2 you release. They will convert all the process into one single unit related to carbon. Okay, so this carbon will directly relate to temperature, okay, which will affect the ecosystem of the whole world widely. And the other one is air acidification. Okay, it's more to a gas called sulfur dioxide, SO2. Okay, and then we also have water eutrophication. It's a way to measure the water ecosystem. How is the level of the of the water system surroundings during when we doing the product design cycles. Okay, so carbon, sulfur dioxide, as well as water pollution. And then another thing that we would not take away is the total energy, especially important in automotive and electronic designs. Right? How to use less energy, how to make the engine more efficiently, mechanically or chemically for the fuel. Okay? So we measure in 4 ways. So here comes what usually concerns to SolidWorks community more. Okay, stage 3, when the company passed through stage 1 and stage 2, when they decide to go for green, what should the engineer be prepared for? Okay, they were actually in charge of designing the sustainable product and service. Right? The challenge is there is 3 things. We will need to have the skill to know which product or service are most unfriendly to environment. We want to avoid those who make a lot of pollution. Okay, in other words, how can I design green easily? How can I get all the inputs easily? Okay. And secondly, the know-hows of green elements and the manufacture of product. Okay. All these materials, what are their manufacturing process? Okay. And how during the manufacturing process, what are the impacts in terms of carbon, SO2, water eutrophication, as well as energy, right? Or in an easier way to understand, how do I calculate the impacts? And the last thing is the ability to generate public support, right? And not be considered as greenwashing. It's a word twisted by brainwashing, right? In other words, how do I make people believe in me? Okay, so this stage, people who involve usually is designers, R&D, or sometimes marketing. Okay, so the other stage 4 and stage 5 would actually be quite operational and business level. So we will be reviewed in our blog post. You can find the blog post after this webinar in this web page, and you can Google CADVision blog post to find it. So we have go through stage 1 to stage 3, right? We haven't discussed what kind of tools SolidWorks can help us. But before that, please allow me to make a conclusion along the stages. Becoming environment friendly can actually lower the cost and increase the revenue. Okay, this is research done by Harvard Business Review in September 2009, where they study 30 large corporations. All right. So here comes the challenge, especially for designers. When you want to tackle the stage, right? What kind of tools or help we can make use of, right? So let me share about tackling the stages using SolidWorks Sustainability. Right. So in every SolidWorks, actually you come with a SolidWorks Sustainability Express. Okay. It's a LCA, life cycle assessment for parts level. Okay. What are the inputs? The inputs is you select material only. No need to select no need to input impacts. Okay, because we have a database to support it. Okay. So in the material, we also have include the mechanical properties, so that when you're choosing materials, actually you can choose the similar mechanical properties for different impacts value. Right? We have a tool called Find Similar that cater for this kind of needs. And then the output is environmental impact dashboard. So we choose material. Okay, we define others stage using, like how many electrical use, right? The whole LCA stage, right? We input, and then the result would be carbon, air, water, energy, right? We directly see whether they the value of this in the part comply to the laws and regulation or not. Okay, and then additional stuff for marketing, for proof, for documentation, for showcase is a customizable, very detailed reports that links to online calculators, right? Auto-generate. Okay. So let's have a look on the demo to see how it actually works. Right. So because of regional internet speeds we have in here, right, I will do this video more slowly. And after this, if you found the demo is very unclear, you also can send us an email to request for a recording. Okay. So this is a hard disk drive. I would like to start using the Sustainability Express to evaluate my part level. Right. So what I do is we'll go here, evaluation, and we go for sustainability. Okay. So we pick our material. The class will go for steel. The name will just go for example, alloy steel, right? And over here, I will click set to baseline. Okay, so meaning that I set currently design one is this value. Okay, so if I want to go in to see carbon, actually what kind of things we have. Okay, we go in, we can see actually manufacturing covering this 0.054 kg of carbon dioxide according to weight and the material used. Okay, so manufacturing use end of life transportation you see very low. That is because we have other stage inputs to put inside. For example, the region is in Asia, manufacturing region. We built to last 3 years. Okay, and the sheet metal, the process we can choose between different process: die cast, extrusion, forge, sand casting, mold, a lot for this kind of material. So we just choose this one, okay, sheet metal operation, and this is the average electrical consumption in the region, right, of electricity, natural gas, and percentage of waste in this region. We also can assign paint. For example, we use solvent-based paint. Actually, it will increase the manufacturing cost. And also the use, where we are shipping to. Let me change to Euro. Okay. And by default, Euro, it will put one by boat, right? Actually, let us add some more train values. We'll ship to our distributors, okay, which is another 2,000 kilometer travel, okay, from the ports. So we have an increase in transportation and end of life. All right. So according to law, I have to end of life. I have to put, for example, 95% at least for this metal part is recyclable. Okay. Inclination for metal, we'll put 0. Actually, this is a metal, we'll put higher, 98%. So 2% will be waste. Okay. So this, after we finish top to bottom, actually we see some increase in end of life. Okay. Throughout the selections, what we do is more to selecting the buttons and not trying to worry about the value so much, because that are all recognize the average industry value, which is researched by SolidWorks and his solution partner, and update every service packs. Okay. Okay. After that, we'll come back to here. So I will set the baseline again. This is a more complete one. New baseline, which is covering all the product stage. Okay, now this is now what we're doing. We look at the pie chart. Throughout the cycles, some of it might be too high. For example, SO2. This one, 2.0 E minus 4. For this part, it's already violate the regulation. So what we can do is we make a quick comparison. What is the design candidates? Okay. So usually for users, what we can change more is the selection of materials and the process. So currently is steel and alloy steel. We can use 5 similar. Right. I want to, here is all the mechanical properties. Material class, elastic modulus, Poisson ratio, shear modulus, thermal expansion density, blah, blah, blah. Right. Currently, I'm using alloy steel. I would like to use a similar class with similar density, okay, with similar yield strength and tensile strength. I'm going to find a similar. Right, I guess this only one steel, right? So we'll try another one. This time, similar. Right, I want it to be smaller. It's okay. 5 similar. Okay, I got a long list of steel. Okay, so let's see ANSYS 1020 co-roll here, or this one. So there is a decrease in this area. How about this one? Okay, there will be no changes on here, but a great changes in water. How about this? How about this? So instantly we can see what is coming out for comparison. So we can go through all the stuff. Wow, this one goes very high. Cast carbon steel, right? I believe we'll stick to cold rolled, which is much more suitable to this application. It's a sheet metal, and they have a substantial, very big improvement in water. Okay, I will accept it. Okay, and I got this comparison, and I think this is a better design. And what I can do next is I'll click a button to generate a report. Right. So what designer do is input the key values for each design stage, and all the result will be calculated automatically. Right. So this is the report we have. Right. This is fully customizable. Means if you want to put company logo or name, everything, or even the arrangement of the report, it is okay. So these are all the summaries for our materials, content, wave, manufacturing process, blah, blah, blah. Regions, manufacturing regions and use region. Material, right? This material cost we allow to input as well. Okay. And this will record the manufacturing values. Okay. What are the electrical consumption? What are the natural gas consumption? Right? Scrap rate, build to last, paint, right? Duration of use, transportation, end of life. Okay. These are our input, and these are the result. Okay. So it shows in the pie stage over here. you can see where from raw material to manufacturing to transportation to use and recycle. Okay, some of them cannot be recycled. The total energy consumed is 1.1 megajoule. Okay, as well as the others values. Right. So this value is the support for us to apply for product labels, especially in Euro countries. Okay. So this one is the baseline. Baseline can be think of previous design. Okay, so we can directly compare with the previous design. Right, over here. So the black one is the previous design. The green one is the new design. So we can directly see what kind of stages actually we make changes of our impact. Okay. Over here we can see that is if we change this material, actually it saves a lot of water pollution away during the material process. Right. But it increased some waste in the manufacturing process. But overall, it's still worth the case because the save in material is much more bigger than manufacture. Right? Okay. So let me go back to here. This is more why we can see in overall a pie overall macro view, as well as we can break down to a more detailed view. Okay. Okay. So this is more to a part level what we need to do to finish an LCA analysis. Okay. And we also have the capability to do assemblies, right? We call it SolidWorks Sustainability, which is another add-in that could available in SolidWorks platform. Right? So everything is the same, but we have extra things to do is we can do LCA of assemblies. Right? We support configurations, which means sometimes we put different product version in different country in different configuration. It is very easily to change different parts, different version, and refresh the report very effectively. Right? And we are able to specify the amount of energy consumed during use. Okay? Right? And this we can do it in Express as well, transportation. But this time the use and transportation is in assembly level. For example, electronics, mobile phone, right? And we also support assemble visualization. So this is a very important tool not only for sustainability but also the other daily operation. So let me show you about these features in SolidWorks. So I have a humidifier over here. Okay. So this is a personal humidifier inside our office. Right. As usual, we can go for sustainability. Right. Let's say we manufacture in Asia. We build to last 5 years. And if you wish to make it more detailed, we can include assembly process as well. How much the amount of things we can calculate based on the time we need to assemble this assembly. Maybe we put it, for example, 2 kilowatt per hour, simply one part. And then the use, okay, will be in America. Nice span, right? We will plan to use, for example, 4 or 5 electrical. Okay, we have different fields. For example, 200 kilowatt per year. Okay, it's a very light one. And set up our transportation. I'll reset to default. And some trains. some cars, okay, before they reach to our consumers. Okay. And end of life, and instantly we'll see all this result coming up, right? So most of it is during use. Okay. So we can go here for assembly visualization. Okay. So this is a very useful tool for assembly. In assembly visualization, we see a list of parts. Okay. And here is the bar is whether the value is high or not. So what are the value? In here, the default is total weight. We are calculating, see which part is the most heaviest part. Currently, it's top cover. But it's assembly, we're trying to look for some other things. We can go here for example, sustainability carbon. Which one is consuming more carbon? Which one is I need to fix the design to meet the requirement? So we can set the color. Let's make the top one red and the bottom one green. Okay. So here by here we can adjust. Okay, let's say this tool is out of the our derivative. Okay, we need to make it smaller to meet the value. The blast. Okay, PEI plastic. Okay, let's find a similar one. Similar density. Okay, and similar tensile string. Find similar. Right, it's not available, so I need to edit. Maybe I make it looser, bigger tensile string. Okay, I find this polyether ketone, if I pronounce this correctly, but it goes very high. Let's keep sourcing. Perhaps I will make it lighter and stronger. Right, we have quite a lot. So let's see which one is better. Right. I think we will use polyester resting since it shows very good improvement. Right. So the rest we put default, we see the changes. So it dropped down below 1. So this is a good improvement. Currently we'll look at here. Okay, so with this assembly visualization, we are interactively look at the change of our design in an assembly level. Okay. So we still have one very out of stage. So let's look at this as well. So this one, currently we are using also PEI. Okay. So the thing is, inside SolidWorks platform, what we do is, this plastic actually, they are facing some pressure and loadings, dead loads during the use as well. Okay, so at the same time we will do some simulation, stress strain analysis in our SolidWorks platform. Okay, so the condition is here we have some force at the bottom since it's located on the table. Okay, and also we have some pressure on the inner wall of the plastic cover. Okay, all of the internal space. So what would it be if we're using the existing material? Right, let's check on the result on how it goes. Okay, so we directly go and look on the displacement to check whether it deformed correctly under pressure. Yes, this is the correct movement. And we can go to check factor of safety. Okay, let me adjust 1 to 10. Factor of safety, the value is higher, the more safe we have. So if we have yellow zone or red zone, this is a more critical area. So the minimum factor of safety is 2.4 using PEI. Okay. So let's go back to assembly. So I'm doing this conjunct design between simulations, okay, stress analysis, and green design. So for the clock tower, what we want to do is we want to keep at least the factor of safety don't be lower than 2.4, but we have lower environmental impact. Let's go back to here. So let's find a similar material, and we go for similar mass density. We want to keep the wave of transportation as well as handling, okay, smaller. We only can do smaller, but then we want to make it stronger than self stress. Find similar, right? So like this one, we'll choose back polyester resin. Okay. So accept and update. So we'll go down to 1.2 kg for carbons only. Okay. And then we'll save the assembly. So what interesting fact is the change of material in SolidWorks sustainability actually goes to the part level as well. So when I reopen the part level, right, okay, let me close again and open again. Right, I think I better do it here. Density smaller, tensile strength bigger. Okay, we use okay, let's go and assign a material for our plastics. So we have an extra material called Sustainability Express. Right? We use plastic polyester resin, apply, and we just go and run. See the factor of safety. Okay, so it goes up to 30, a very high value for changing the material. At the same time, reduce the environmental impacts. Right? So design for environment, design for shrink are both achievable at the same time. Okay. So thank you for joining this webinar. Now is the Q&A question. Do you have any questions? You can feel free to type a chat out here. Right. So if you have no questions, but you always can feel free to contact me at lionscad-vision.com or give me a call at 017-678-3988 if you need further support or inquiry. Okay? So thanks for joining the webinar today. Hope to see you on next session. Goodbye.